Hi guys, in this video, I am going to be going over one of my favorite skills in algebra, and that is factoring. This is something that we have done in the past in this class. You've done it in the past in Algebra 1, and it's something that you'll continue to do in this class and to the next level because it's so important and it's so embedded within all of mathematics. So, I'm going to be going over examples 2 and 3 in this video, and hopefully it gives you a good idea about what you're looking for when you're factoring. So the first problem says, factor to form an equivalent expression. So everything we're doing is about equivalence right now. So I have 3x squared minus 8x plus 4. Now, the first thing I do is I multiply 3 by 4, and I get 12. Once I have 12, I go off to the side and I write down my factors of 12. 12 is 1 times 12, 2 times 6, and 3 times 4. Now, one thing to keep in mind here that's really important is the signs. So here I have 3 times 4 and I get positive 12. So the two different options you have for positive 12 is a positive times a positive or a negative times a negative. Now I look to the inside and I select one of these pairs. I select the one that adds to the middle term. So I need to add to negative 8. Since I need to add to a negative number but multiply to a positive number, I need my pair of numbers to be both negative. The only way that they're going to multiply to a positive but also add to a negative is if they're both negative. So I've got negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. I write all of them out so I know what my options are, and then I make my selection based on what the middle term is. So this tells me that negative 8 splits into negative 2x minus 6x. Now I think you can all agree that negative 2x minus 6x is the exact same thing as negative 8x. So that's what I mean by equivalence. So once I split the middle term, I also bring down my outside pieces, so 3x squared and 4. So now I can really see that this expression here is equivalent to this expression here. But all I've done so far is split the middle term. So now what I'm going to do is I'm going to factor out the GCF of the front two and factor out the GCF of the back two. So I'm looking at what the greatest common factor is of each of the two pairs. So the greatest common factor of 3x squared minus 2x is just x, or 1x. When I take out x, I am left with 3x minus 2. Notice that x was brought in front, and I got 3x minus 2 by dividing 3x squared minus 2x by x. In the back two, I take out my GCF as well. 6 and 4 both have a factor of 2 in it. Now, I always say that if the first term in the back two is negative, you're also going to take out a negative. The reason for that is because we want the two inner pieces that are left over to be the exact same. And if I only took out a positive 2 here, I would get negative 3x plus 2. But I want positive 3x minus 2. So to make those signs opposite, I take out a negative. So I take out negative 2. And when I divide by negative 2, I get positive 3x minus 2. Now I can see what I call, very unofficial, I call them my twins. So 3x minus 2 and 3x minus 2. So now I'm factoring out 3x minus 2. And I'm left with x minus 2. So one factor comes from the twins, and the other factor comes from the coefficients of those. So my fully factored form is 3x minus 2 times x minus 2. All right, I'm going to do one more example. So I have x squared minus 5x plus 6. So the coefficient of x squared is technically a 1. So when I multiply, I get 6. If I go off to the side, the factors of 6 are 1 times 6 and 2 times 3. Now again, I need to multiply to a positive 6, but I need to add to negative 5. So I'm going to need 2 negatives in order to multiply to a positive, add to a negative. So the 2 that add to negative 5 are negative 2 and negative 3. So I make that negative 2x minus 3x. Bring down the outsides. And now I'm going to start taking out GCFs. So if I take out x here, I've got x times x minus 2. And in the back 2, I would take out negative 3. Notice since this is a negative, this is a negative. Take out negative 3, and I'm left with x minus 2. Here are my twins. So one factor is x minus 2, and my other factor is x minus 3. This is my fully factored form. One thing that people ask me very often is, does it matter which order you put your middle terms in? So does it matter if this was negative 6x and this was negative 2x? The answer is no. The only thing it'll change is what you end up taking out as GCFs and the order of what you see here. But that does not matter. X minus 2 times 3x minus 2 is the same thing as 3x minus 2 times x minus 2. So the order you put those x's in does not matter, but you should always pick the same 2 as someone else did. There's no way to pick a different pair that would work. So there's always going to be one real answer for how you're going to split the middle terms. All right, so that is factoring just a standard quadratic trinomial.